All right, so so now the next thing after the qualitative and quantitative thing, and if you remember the different learning things that I talked about yesterday, the different objectives, we covered the first three. Okay, the first ones, remember, was define statistics and statistical thinking, which I think we did that. The process, those were those 4 steps that we referred to. And then we distinguish between qualitative and quantitative. So we got to the third thing. Today we'll do 4 and 5, and then the rest of the time will be for you guys to work. So 4 is distinguish between discrete and continuous. And then number 5 is determine the level of measurement of the variable. So that's what we have left, is just those 2 parts. So the next 2 things that we have are discrete versus continuous. Okay, and so here's how they define it. Continuous, I'm pretty sure if I just asked you what you thought, you'd probably hit it on the head. Discrete might be a little bit different, but what their definition is for discrete is a quantitative, so it's quantitative, variable that has either a finite number of positive or possible values or a countable number of possible values. So basically you can count them, okay? And you can have a finite. So this is a quantitative. And you have a finite, which again, the word finite means that it's a countable thing or a start and a stop. And you can count them, okay? Continuous, if I asked you to define that, you'd probably say about, almost maybe not quite finite, right? It might be one of those things where it's more infinite, where it goes on forever and maybe you can't count them. So what continuous, how they define it, is a quantitative variable. So again, it's got a number value to it that has an infinite number of possible that are not counted. So that's the difference between them, is something that you cannot physically count, okay? And if I asked you to define continuous before you even started with that, before I read those definitions, would you agree that that's probably something you would have thought? Yeah, that it probably does go on forever. And so it also goes on to say the term countable means that the values of the results from counting, such as 0, 1, 2, 3, and so on, a discrete variable cannot take on every possible value between any 2 possible values. And then the continuous part also says a continuous variable may take on every possible value between any 2 values. So like your decimal points, right? Think about all the numbers between 0 and 1. At first, when you, depending on the age of the student, when you think about like a younger kid, when you ask them what numbers are between 0 and 1, they might say nothing. They might say like, there's nothing in between there. But then as they start to learn about decimal points and everything else, how many numbers are actually between 0 and 1? Too many to count. Okay, that would be a continuous, is what they're referring to that. Okay, does that make sense? All right. So then the example that they give you is, it talks about, again, determine whether they are discrete or continuous. So the number of heads obtained after flipping a coin 5 times.
Discrete.
Yeah, why?
Because it's not infinite, it's 5 times.
Yeah, it's 5 times, it's not infinite. There's only head or tail, right? And you're right, it's only 5 times. It's not saying we know exactly how many we're going to flip, okay? So that would be discrete. How about the number of cars that arrive at McDonald's drive-thru between noon and 1?
Discrete.
Okay, why?
Because you just sit there and count how many show up during that time.
Yeah, and the other thing is that it also says it gives a certain time, right? It gives from noon to 1. It doesn't say like within a year or anything like that. Like that might be a hard thing to do, although they do that. When I was in high school, I worked at McDonald's, so I know they do stuff like that at the drive-thru to figure out like times and make sure that you are getting a faster time every time or all that kind of stuff. So they do actually track that stuff. But you can count that. Like we can figure out how many there are. How about the distance a 2014 Toyota Prius can travel in a city driving conditions with a full tank of gas? Is that something that would be discrete or continuous?
I would have thought discrete, but it says continuous in the solutions, but
Yeah, and here's why. Like, remember yesterday we talked about how some answers could vary,
yeah.
right? And why do you think you would say discrete?
Because like it gives you the amount for how much miles. I mean, it's an estimate, but it still says you can go X miles with however much gas you have.
Mm-hmm. And the reason why they say it's continuous is because of the fact that, and this is where the wording of the question might just be careful, because it just says the distance. It doesn't say miles. It doesn't say how, like, it doesn't say what thing. So if you have it in miles, then I think it would be discrete, because then it has a definite thing. But it didn't say that, and we have other avenues of measurement, like if I'm up in Canada, meters, or even in our own customary system, we have miles, feet, inches, like all those things start to add up and change, and then it gets to be too much. So that's why they're considering continuous. However, that would be a case where, as long as you could have an argument to say about it and actually word it out okay, like if you answered the question and said you thought it was discrete and maybe a little why, as long as that why makes sense, I would give that to you. Okay, so just so you guys are aware of that, I think that there is a couple of these that could have different or multiple answers. Okay, as long as you can reason it out, it's going to be okay. All right, does that make sense? All right. So again, it also goes on to say then continuous variables are often rounded. For example, if a certain make of car gets 24 miles per gallon, its miles per gallon must be greater than or equal to 23.5 and less than 24.5, and so on. So it's got a little bit of a range to it. Very similar to, for those of you who were in college algebra last semester, that when we talked about the Richter scale, remember it was only like 4.9. It wasn't like 4.96234 or whatever like that. It was always just the one decimal place. So a lot of times it's a rounded thing or whatever makes it easier for especially the consumer to look at. And so the types of variables, whether it's qualitative, discrete, continuous, because those are the two quantitative ones, dictates the method that can be used to analyze the data. The list of observed values for each variable is the data. Okay, so when you have a list of all your stuff, that is your data. Gender is a variable. The observations male and female are the data. That's the example of that. Okay. Qualitative data are observations corresponding to qualitative variables. Quantitative data are observations to quantitative. And then it goes on to say that they're, discrete data and continuous data are the same for those. So the next example that they give you is they give you a table, and it says, Table 1 presents a group of selected countries and information regarding these countries as of July 2014. Identify the individuals, the variables, and data in Table 1. Okay, so individuals are the part that you are, or the people, or what you're doing. The variables are obviously like what type, and then or which of the data it is. So when you think about Table 1, it's got that list up there, and it says the countries, and it gives you Australia, Canada, France, Morocco, Poland, Sri Lanka, and United States. Government type, it gives you those types. Life expectancy and population in years. That's the table that it gives you at the top of page 9. So the individuals for that particular thing, when it's asking you to identify that, are the countries. Okay, those are the different types of things that we are looking at, is we're looking at each country individually. Okay, does that make sense? Then when it goes on to say the variables, okay, the different types of variables that we have on there, there's 3 different ones that they have, okay? The different variables that they give you in that table, they give you government type, whether it's a federal parliamentary democracy, constitutional monarchy, republic, all the kind of different things. Okay, those are one of the things that's a variable. The other variables are what?
Life expectancy and the population.
Yeah, life expectancy and the population. Okay, those are the variables that they're trying to identify. And so from there, it also said identify and the data. And so from the last part, is the government type qualitative or quantitative?
Qualitative.
Okay, why?
Doesn't have to do with numbers or anything.
Okay. What about the life expectancy? Is that quantitative or qualitative?
Quantitative.
Okay. And then population, would that be quantitative or qualitative?
Quantitative.
Quantitative because you're being able to count them. So again, this would be qual, quant, quant. And those are Q's, just so you know. That's a cursive Q, lowercase, for me. All right. And then as far as the rest of it, diving into the quantitative, just one more little spot. Would the life expectancy be discrete or continuous?
Continuous.
Why?
Because, like, you can't really count it, and it's like there's so many that go into it, like multiple variables.
Perfect. Yep, exactly. Okay, that would be continuous because of the fact that there's so many different variables or so many different numbers that are in there. It's kind of like that analogy I used from, well, how many numbers are there between 0 and 1, right? It's too many. What about the population? Is that discrete or continuous?
Discrete.
That is discrete because when you're thinking about populations of countries, we can count how many people. We know that, like from birth records and all that kind of stuff, right? So we know what a population could be. That's discrete. It can start and stop. Whereas the life expectancy, because all those different things that go into it with the decimal points and whatnot, we can't. And so that's why that one was continuous. And this would be discrete. Okay? So when you have a question like that, that's what they're going to ask you is identify the individuals, identify the variables, and the data. And the data is just basically saying, is this continuous, discrete, or is it qualitative? Which you did. Okay? Does that make sense? Is everybody okay with that? All right. Then the last thing that we got to go through, and this will be pretty short, is determining the level of measurement. And so there's 3 or 4 different types. First one is called nominal. And nominal, the variable is at a nominal level of measurement if the values of the variable name, label, or categorize. In addition, the naming scheme does not allow for the values of the variable to be arranged in a ranked or specific order. So, nominal, a lot of times what I say is the variables are named. Like the countries, okay? The countries were nominal because they were named. They weren't ranked order, were they, in that table? No. What ranking are you going to go by? Are you going to go by the government type, life expectancy? It didn't tell us that. So nominal is just a way of naming them, okay? Then the second one is called ordinal. Now, what I equate this to help me out, ordinal looks like the word order, right? Do you see that at the beginning? Ordinal and order. If you put things in order, then it's ordinal. And it's still naming, okay? It's still nominal, but in order. And things like that, as an example, would be how our government is with our president, our vice president, Speaker of the House. Like there's a rank order there, okay, where it goes from the top down. If you're in a monarchy, you know, king, queen, prince, but like all the different, like how things are going. President, vice president, like those are ordinal, okay? Because they're still named things. However, there is a specific order that they have to follow. Okay, does that make sense for ordinal? All right. Then the next one. Interval level of measurement has properties of ordinal, and the differences in the values of the variable have meaning. A value of 0 does not mean the absence of quantity. Arithmetic operations such as addition and subtraction can be performed. Okay, so it does have the properties of ordinal. However, the differences have meaning. Okay, and so when you think about interval, a lot of times when we have an interval, it's like 0 to 9, 10 to 19. Like you see a space or a gap in between there. Okay, so has ordinal. And differences in the values. So these are more numbers a lot of times. And the last one is ratio, which a lot of times when you think of ratio, a lot of times people forget that a ratio is nothing more than a fraction. Okay? It has properties of interval, and the ratios of the values of the variable have meaning. So for instance, it says something like, right now, currently, we are 4 to 1 in the room. 4 males to 1 female. Okay, that's a ratio, okay, of the measurement. And so for that particular purpose, that's an example of it. So it has properties of all the ones above it. However, it also has ratios. The ratios have meaning, okay? Has interval, and ratios have meaning. So again, what they're going to ask you is very similar questions to before. For each of the following variables, determine the level of measurement. It's one of the 4. So you have a 25% chance of getting it right. Gender. Would gender be nominal, ordinal, interval, or ratio?
Nominal.
Yeah, why?
Because it's only names.
Yeah, it's only names. Perfect. Okay, there's no order there, right? We're not saying that one is better than the other, or we're not saying that one is higher on the whatever than the other. We don't have numbers attached to them. So yeah, it's nominal. Very good. What about the temperature?
Interval.
I would go interval on that one. And the reason why is because we're not naming it. It doesn't have names anymore, right? Temperature is degrees, whether you're in Celsius or Fahrenheit. Ordinal, we're not ranking order on it, but we can put them in intervals, can we not? And make them go like, hey, how many days was it between 0 to 10 and 11 to 20 and all that kind of stuff? We can easily do that. I don't think we would count it as a ratio though, right? It wouldn't go that far. So interval, I agree with you on that one. How about the number of days during the past week that a college student studied? Would that be nominal? Not really. Okay, because it says the number of days, right? Would it be ordinal? No. Interval? Maybe. Could it also be ratio? When you compare it to other days, yeah, it could be. Like you could say easily, let's say I studied Monday, Wednesday, Friday. How many days did I not study then?
2.
Yeah.
It's 3 to 2.
So that'd be 3 to 2. So that would be the idea of a ratio. Does that make sense? Days studied to not. Okay. And then letter grade that you earned in this class. What do you think? First of all, it's not a number, so it's not interval or ratio. Would it be nominal or ordinal?
Ordinal, probably because like A, B, C, D.
Yeah, it's got order, right? A, B, C, D. Hopefully not in the last ones, right? Hopefully in the top 2, at least. Okay. So, what do you think? Again, for most of the problems in here, it's gonna ask you to tell me if it's, like looking at what I gave you, it's gonna say classify it as qualitative or quantitative, tell me if it's discrete or continuous, what's the level of measurement, identify the population and sample, that type of thing. It's gonna go pretty quickly for a lot of it. And so just so you guys know, that's kind of what we're doing. If you want to abbreviate some of your things too, that would be okay. In the past, I know some people, especially for like these ones, they put N, O, I, and R. That would be okay for me, okay? Just so that I know. But if you don't want to write out the whole word, that's okay. All right? But a lot of times it's where you have one or the other. Just remember the difference between some of the other things like parameter and statistic. Parameter is population, statistic is sample. Okay, so, and then qualitative and quantitative, and then continuous and discrete. So, any questions on all that stuff? It's a lot of definitions right away, isn't it? Yeah, chapter 1's full of them. Sorry, you guys. But so, I know I already posted it in Classroom. So, if you want to look there, that's where the assignment is, and I'll shut up and let you guys work.